Hello everyone. Welcome to this section on time series analysis. In this video, we're going to talk about time series analysis at some length. We do encounter a lot of time series data in our day-to-day exercise as data science professionals. Mastering the skill to draw meaningful insights from such is a top requirement. The next topic shares a snapshot view of the journey map for what we'll be covering in this video and subsequent videos. It starts with a formal introduction of time series data and its key characteristics, its various components, some major mathematical concepts around time series data, and then discuss about one of the mainstream approaches to derive forecast or future prediction for the time series data. We will also discuss about the important measures for the evaluating forecasting accuracy of our model. Finally, we will conclude with a case study. So this is for the solution part for homework exercise, where we had asked what we can actually do to deal with the class imbalance related problem using Naive Bayes algorithm. We actually used multinomial Naive Bayes, but there is another type of Naive Bayes algorithm which is quite effective for imbalanced dataset, and this is called complement Naive Bayes. For more detail, please visit the official site of scikit-learn. But here in the solution of this exercise, we will take you through the implementation of complement Naive Bayes for this particular datasets and see if it gives us little different results after it takes care of for the class imbalance. So I think again the alpha parameter that we are using, which is Laplace or Lidstone smoothing parameter, this is set to 1. In case you feel like, you can change it to some other values and see if there is any change in the results. And post that, we simply apply, and here you see one interesting aspect. Your area under the curve has certainly gone up, but your overall test accuracy is kind of little low. Let's compare it, because now it is no longer an imbalanced predictions or an assessment that we are making. Here we are taking into consideration of this class imbalance, and the Naive Bayes algorithm accounts for that imbalance and adjustment in its prior probabilities calculations. So let's see how the overall performance looks like. Definitely the accuracy has gone down, but if you look into the individual precision and recall, let's say for the event, it has definitely improved. In our normal multinomial case, it was merely precision was 66% and recall was 19, whereas it was 90 and 99 for the zero event class. But here if you look into this, it has gone up obviously, and the percentage recall has significantly gone down for 0. Let's see how it has transformed the decile report. The lift have not shifted, or it has not changed much, but if you look into the predicted mean and compare it with the actual, you will see that the prediction is sort of giving you an overestimated value of in terms of the prediction. So for example, in the top decile in our previous exercise, we do see the predicted mean and actual mean are quite close in terms of their magnitude, like 0.48 versus 0.44, whereas here in this exercise it has almost shifted to double. So these changes are kind of quite expected because of the weight shifts and the change in the prior probability estimates. So that's what is resulting into that. But complement Naive Bayes could be really very effective in presence of class data imbalance. So I'd like you to explore more options around it and see what type of results you are able to generate, and compare them with the existing piece of solution. See if you can outperform any of this existing one. Introduction to time series analysis. Time series is a discrete or continuous sequence of observations that depend on time unit. Time is an important feature in many natural processes such as air temperature, pulse of the heart rate, etc. It is also important in many business processes such as the total units of a newly released book sold in the first 30 days, or the number of calls received by a customer service center over a holiday weekend, inflation rate, etc. Time is a natural element that is always present when data is collected. Time series analysis involves working with time-based data in order to make prediction about the future. The time period may be measured in years, season, months, days or hours, minutes, seconds, or any other suitable unit of time. Serial dependence is the key feature of a time series. This means that an observation today is potentially influenced by previous observations or autocorrelated. To take advantage of serial dependence, time series model use past observations as a basis for predicting the future values. So the time series data is typically characterized by its own time-dependent internal structure like autocorrelation, trend, seasonality, etc. Unlike cross-sectional data, as highlighted here, where the data is collected in a particular point in time, time series data are collected over a specified time horizon and therefore has a natural temporal ordering, which is absent for any cross-sectional data. It's now time for discussing about different components of time series data. Now, a time series can potentially be decomposed in 4 key components. The first one being the level, which indicates the mean or average value of the series. A trend means long-term increase or decrease of the values of the series. Some seasonal effect like seasonality, when the series is influenced by some seasonal pattern or factors like overall sales might be influenced by several holiday seasons. And the last component would be irregular components, sometimes referred as the irreducible error in the series. After taking care of all the components, there could be some variation that cannot be potentially captured through the structural components of a time series model. And such elements are referred as irregular components. Now, based on these elements, time series can be represented by either an additive model, aggregate of all the 3 elements except the level, or a multiplicative model, product of all 3 elements except the level.